Hello, everyone. Welcome to our new webinar of Destination LoRaWAN, a virtual series of webcasts organized by the LoRa Alliance. Today, February 16, we are going to present you a topic about protect water. 3 billion humans will face water stress by 2035, as said by the World Health Organization. It's already critical in some of our countries, in Australia, in California, in Africa, of course. In many other areas, there is water stress. We will take that topic together. But before that, let me share with you some keynotes, the rules for telling you that all questions you can submit through the Q&A engagement tool by written. You will have written answers during the session or later by emails. The webcast will be available through an email link sent to you in the next 48 hours. You can have also other content available on the LoRa Alliance platform. Without further delay, let me introduce you our panelists who will today present to you how the IoT with LoRaWAN can tackle the challenge of protecting water. It's my pleasure to welcome Pierre-Emmanuel Dubois from Birds, Xavier Broise from AquaLabo, Dominique Deschangy from Strega Technologies, and Sylvain Spenle from Robo. Water is a scarce resource for humanity. We are all living on a blue planet, plenty of water, but bad surprise, only less than 3% is pure water. More than this, we think that the most important is drinkable water, but most of use of clean water is for food, for irrigation. It's also for energy, also for other washing purpose, etc., in residential or building areas. Last, in industry. What's wrong with protect water? What are we doing wrongly? What is the, I would say, urgency? What do we have to change? That's exactly the point addressed by the United Nations when listing the Sustainable Development Goals for humankind. They call world to change for a safer and more affordable drinking water for all by 2030. We must realize the fact that 80% of wastewater is untreated, and still 844 million people lack access to drinkable and sanitation. The stress over the world is affecting many countries. It's one of the key goals to improve this. The definition by the World Health Organization is when water availability is less than 1,700 cubic meters per year per habitant. The map shows the average exposure of water users in each country to the baseline water stress. It's the ratio of total withdrawals to the total renewable water supply in a given area. Higher percentage, from yellow-white to dark red, means more water users are competing for limited water supplies. And today the reality is 2 billion. So in the next 15 years, if we don't change, this number will increase and reach up to 3 billion. How the technology as LoRaWAN for connecting IoT sensor can help us to change that. That's one of the reasons why LoRa was designed for providing better performances to low power water meters used in metering for water, but also for gas and other utilities. But those water networks are suffering because of aging infrastructure, because of misoperation, because of some water leaks due to corrosion or other potential issues, such as waterworks or misoperation. So by average, more than 24% of the produced water is lost over the network. Where again can we change and improve this? Through, let's say, a water cycle, an artificial one, not the hydrological one, we try to represent how the IoT in different key points can impact for the best the use of water sensors, such as quality sensor for pumps or other pollution control systems or metering systems, water leak detection, etc. All types of new sensors then can profit to utilities to improve the efficiency. Without more, I would say, delay, let's look at the solution provided by one of the most important player in the sector of water supply, the company Birds of Veolia.
Thank you very much, Rémi, and good afternoon to everyone. So my name is Pierre-Emmanuel Dubois. I'm an international business developer at Birds. So first, if you let me, I'll share a few words about Birds' activity. So Birds provides environmental smart solutions for industrial IoT. As a 100% subsidy of the Veolia Group, Birds is the IoT digital center, competence center of the group, serving customers such as municipalities, commercial or industrial companies, both inside and outside of the Veolia Group. Our domain of expertise lies in environmental verticals, monitoring on daily basis environmental data such as water, temperature, humidity, waste collection, or indoor air quality, and many others. We operate more than 3.2 million connected devices every day through various LP1 technologies, including LoRaWAN. LoRaWAN fast deployment represents a significant booster for smart water service adoption and enables a more effective water service at a managed cost. Currently, Veolia and Birds are deploying in France over 3 million smart water sensors in the next 10 years on a public LoRaWAN network through Orange and powered by Activity. Before going any further, let's have a quick look at a water network and all the process from raw water resource to water consumption. This is called the small cycle of water, which Rémi was introducing earlier. So step one, the source itself. So the water usually comes from surface water like lakes, rivers, or reservoirs, but sometimes it can come from groundwater and be pumped up via wells. Step two is the treatment. The water then gets treated to remove any dirt, chemicals, or organisms that may be harmful to people. This process involves filtration and disinfection to make sure that the water is safe for us to drink. Step three is distribution. The water is then sent out through the water pipes network to areas of the cities where it is needed. In step four, the quality monitoring helps municipalities ensure a high level of potability, reduces risks on network incidents, and alerts on contamination. Step five is the storage. So after being distributed and checked for quality control, the water is stored in water tanks before it's used. And finally, the use, and that's how the water arrives in our taps and showers. How to measure water quality and how? Capta, which you can see here, is Bird's smart water quality solution. Monitoring water quality is crucial for water utilities and municipalities, as they have a commitment to permanently deliver a high level of water quality from production to end consumer. The World Health Organization has defined key parameters for the monitoring of drinking water, including connectivity, absolute pressure, temperature, active chlorine, and others. Why measure water quality? Well, first, to ensure a constant high level of water quality from production to end consumer. Second, to improve the management and the monitoring of the drinking water supply. Third, to reduce the impact of water network incidents. Fourth, alert on contamination. And finally, supervise critical locations as a stepstone for city resilience. Capta is deployed in 12 countries worldwide and protects in France only around 8 million people. Capta has been rolled out for large international events or venues such as Euro Disney in Paris for the COP21 and in London in the 2012 Olympics. As you can see, Capta is directly installed inside piping systems. It is fully autonomous in energy and connected through mobile connectivity. And it can also be served, of course, in LoRaWAN through the Luca module, which combines LoRaWAN and with blockchain traceability. And through this solution, Perch digitizes the monitoring and protection of surface water and contributes to the preservation of the quality of the water resource. The Swarm system is an innovative solution by Birds for monitoring the quality of surface water. Currently, if you wish to monitor water quality, a sample usually is taken and sent out to labs with the results coming within 3 to 4 days. Swarm, on the contrary, allows you to monitor water quality in real time. The buoy measures the water quality parameters and transmit data in real time for analysis. On top of the measuring system, the buoy comprises an anchor, a float, and an energy generating module allowing self-sufficiency. The buoy can be installed directly and easily on any type of surface water. Using the Swarm system, the water supplier can continuously monitor changes in the 7 parameters for the quality and condition of surface water. Hence, deploying Swarm is a guarantee for municipalities to protect the assets of surface water resources, rapidly detect the variation in water quality, limit the economic impacts of any type of pollution, and secure the water resources against accidental contamination of malicious acts. Swarm, let me emphasize on the experience of the Swarm project deployed in Coliban Water in Australia in 2018. This project had 2 objectives. Objective 1 was to measure in real time the blue-green concentration in the reservoir. The second objective was to optimize the downstream water treatment. The trial with Coliban Water was mainly about testing the buoy in harsh conditions, and it came out with very positive outcomes. First, the model self-learned to account for oxygen evolution at daytime and nighttime. Second, the model has also been able to determine both algal and bacterial concentration. And moreover, an artificial intelligence model was built to predict how turbidity varies over time. And that model can now predict the turbidity over 30 days. As a consequence, if turbidity increases above the limit threshold, then an increase in chemical dosing is required. In order to support you in the integration and deployment of any LoRaWAN-based IoT project, Birds has launched to the market an environmental IoT data platform called IoT Drive. IoT Drive is basically a software as a service data integrator and management solution. It is fully agnostic of sensors, regardless of their manufacturers, agnostic of software applications, and of environmental use cases. In other words, it is the Google translator, I would say, of the IoT complexity. In terms of pricing, IoT Drive comes at a very competitive cost with a yearly subscription fee per device, which is highly competitive compared to alternative solutions. IoT Drive is besides way more plug and play than these alternative platform solutions. Birds and myself are here to support you on any of your environmental LoRaWAN-based IoT projects. So please do not hesitate to contact us. We'll be happy to get in touch. And thank you very much for your attention. And I will now leave the floor to Xavier from AquaMode.
Thank you very much, Pierre-Emmanuel, for your explanations about your multi-parameter probe and for this case in Australia. Now let's talk about water quality monitoring and pollution detection for wastewater treatment plants and surface water. So my name is Xavier Broise, and I'm the Vice President of the company AquaLabo. AquaLabo is a manufacturer of smart water quality sensors. Today, I will introduce our digital sensors and the AquaMode, which is an emission LoRa module that can be used with our probes. As you can see on this slide, we have developed a wide range of sensors for multiple parameters: optical dissolved oxygen, pH, conductivity, optical turbidity, optical TSS and sludge level. And we have recently launched a UV254 sensor to measure COD, BOD, and TOC in the water. So what are the USPs of AquaLabo sensors? First of all, the sensors are smart. All the intelligence is done inside the sensor. Calibration, compensation, ranges management are done in the electronic of the sensor. So you get a digital signal with a water quality value that you can immediately use for your process. The second point is the low power consumption of the sensor. As you can see on the slide, when you don't measure, you can use the standby mode, and your consumption will be between 25 and 50 microamp. If you request one measurement every second, for example, your consumption will be between 4.4 to 11 milliamp. Each sensor comes with a fully open Modbus and SDI 12 protocols. So together with the sensor, we provide you all the information to configure our sensor to your Modbus master. As you may have understood, so your sensor is a slave and needs to be managed by a master. We have developed the AquaMode, which is able to request a measurement to the sensor. So your AquaMode will be the master. The AquaMode will be able to send the data to a LoRa platform because it has a LoRa emission capability. Also in this gate, we have a small Wi-Fi system, so you can use your mobile and Android application if you want to take access locally on the sensor, if you want to make the maintenance of the sensor, if you want to do the calibration of the sensor. So now let's see some application where this package can be useful to monitor water quality. Industrial and domestic wastewater must be treated. So as you can see on this slide, the treatment process is composed by different steps. And the challenge is to discharge at the point number 6. So you can see on the slide, the outlet point number 6, a water that fits with the regulation given by the local authorities, and to make sure that you don't pollute the water. In the process, we will remove the contaminant in the water. So we have physical, biological, and sometimes chemical processes. For each treatment, water quality is required, water quality monitoring is required to optimize and control the process. So for example, plant, we will measure dissolved oxygen in order to optimize the blowing system, measure the pH to optimize the dosing of the chemical product. Industries also use a lot of water, as we have seen in the introduction, for their processes. And they have two main options for their wastewater management. The first one is to have their own wastewater treatment plant, an industrial wastewater treatment plant. And the second one is to pay a fee to the local municipal water treatment plant and just send the water to this plant. But in any case, they have to measure the water quality they discharge to prove that they do not pollute. So the rules are different in each country. For example, in India, CPCB regulations impose the water to monitor some water quality parameters, and this organization has fixed some target values to be reached. At the beginning, in India, this administration was targeting the biggest industry. Now, step by step, they also target smaller industries. So the market for water quality monitoring for industries in India is bigger and bigger. In Europe, we have some water agencies. We can call them also police of the water. And each industry must find an agreement with the administration according to their activities, according to the volume of water they discharge, about the monitoring they have to do. So sometimes they just need to install a very simple stationary sampler and take some sample and go to the lab. But sometimes they also have to measure water quality online. Another very interesting market is fish farming and aquaculture. This market is booming at the moment, and fish farmers may need our technologies for 3 reasons. The first one is to optimize their production process. They need to keep a certain level of oxygen in the water for the fish, and they need to optimize the feeding system. So they will monitor dissolved oxygen and turbidity in order to save energy costs and feeding costs, which are 2 major expenses in a fish farm. The second one is that a fish farm becomes like an industry because they also create a pollution. So more and more, they have to prove that they do not pollute, and they have to monitor their wastewater. And last point is about the security of the site. Fish farmers to lose all the production they have and to lose all the fish. So for example, in the summertime, when the temperatures are very high, the dissolved oxygen in water is going down. So they may need an oxygen sensor connected to a LoRa system to send an alarm or SMS or an email in case the DO level in the tank is too low. Last application is about surface water. As we have seen in the introduction, surface water is used sometimes to produce drinking water. So when civil engineering companies are working in a river, what they do is more and more control. So for example, if you build a bridge which is crossing a river, or if you do a dredging campaign in a canal, you must measure turbidity before and after the workplace to make sure that this work doesn't have a bad impact on the environment. So thank you very much for your time. And now Dominic will introduce Strega and his solution for water networks.
Hi, everyone. So my name is Dominic Dechangy. I'm the sales director of Strega. And we are coming actually from the telemetry business. So we have a long experience with the water environment, but concentrated on LoRaWAN for the last 4 or 5 years. So what we have developed is the actuator side of the story. So we have developed smart valves, and these smart valves can be installed in many use cases, different use cases. So this shut-off valve that we produce is leveraging actually all the power of LoRaWAN, and one of the main benefits everyone knows is extreme range propagation and ultra-low power. And as you will see, we have gone a little bit further than that by adding several features that are quite interesting for the water and the protect water business. So I'm going to give you a few examples of the technology used for water distribution companies. So before we go into that, I will just briefly explain what we have developed and why is it called a smart valve. So first of all, we have added a real-time clock in the device, which permits to make automation like time-controlled operation. And I give you in a couple of slides the example of water flushing. Another possibility from the device is to make pulse counting. So by coupling the device with a very simple water meter, we can just detect every usage, calculating the values and uploading the information of the counter value up to the control room. We have also some digital and analog inputs. We can control, for instance, the pressure into the pipe. We can detect leakage. And this is another example we are going to explain now. Now, regarding the consumption, we have a little bit oversized the product. It can work on 1 or 2 batteries because we have lots of requirement to fit what the smart metering world is asking for 10 to 15 years of autonomy. Most of the projects we have today are running in Class A, which means running only on batteries. But we have also some other time-critical projects where Class C is requested, and because we are doing a lot of control and what we call downlinks, the Class C permits to control the valve with no latency. So the design is industrial grade. We can work within very high pressure. The valves are rated PN25, so it's up to 25 bars. We can deal with cold water, but also with warm water up to 140 degrees. If the device is used for smart metering, whenever you open the lid, you get an immediate detection of the tamper that is uploaded up to the control room. So let's talk first about a very common example of the usage of the smart valve is for network flushing. Some people call it Perch. The idea is the following. So if a water company has a lot of pipes all over the city, you may have some parts very far away where the usage is very low. It can be only a couple of houses very far away. If the water stays too long into the pipe, you can have the risk to get bacteria. Xavier explained how his sensors can control or monitor that. Well, one of the direct solution that many water distribution companies are doing is flushing the network, let's say 10 or 15 minutes per day, to mechanically get to get rid of the debris and bacteria and all the potential problems, and the water goes to the trash or to the river. With the time control features of the Strega valve, we can fetch into the device to the different timing for opening and closing according to the day and the time, the day of the week or the time of the day. Another example of the usage of the Strega valve is the prepaid or postpaid water. And we see many areas, maybe not so much in Europe, but more in Middle East, Africa, and this kind of countries where you pay in advance the amount of water that you're gonna use. And the LoRaWAN here is perfect for a valve like we produce, because we can again detect the number of pulses coming from a water meter, and when we reach the amount of water purchased by the user, after decrementing the value, it will shut off the valve accordingly. For some countries where closing the valve is not allowed, we have also specific models of the valve where a trickle of 50 liters an hour is sufficient to drink, but not enough to take showers or everything. The last example is leak detection, where we have more and more demand. So the problem with leak detection, or with leaks in general, is that basically you have way more chance to have a water leakage in your house, according to the insurance companies, than a fire or even a theft. So what the Strega valve can do is automatically closing the water mains in case of leak detection. This is done through a wired leak detection sensor, or through a LoRaWAN wireless sensor. And it's either up to the application to detect and to decide to close, or directly from the valve itself that has this smart feature enabled. So now I leave the floor to Sylvain for the other sensors Robo is producing.
Yes, thank you, Dominic, for these interesting business cases about smart water distribution. Now, let's have a look about the way to protect water from end users' perspective. And to start, just a few words about Robo. So I'm Sylvain Spenel, engineer, founder, and CEO of Robo. We are delivering a turnkey solution to measure water consumption in real time and detect leaks in real time also. And we are using, of course, LoRaWAN protocol to help us to cover any kinds of structures, cities, farms, and buildings. We are involved in water protection and conservation, and our commitment is to change the way anybody uses water. So consumers are at the end of the water cycle. And we are convinced that we can help end users to use less and less water by changing behavior and by using right tools like our solution, of course. Indeed, consumers can save water between 20 and 50%. Yes, it's true. Just by decreasing number of leaks inside buildings, it's possible to save 25% of water used. Leaks rate is about 20% in buildings in France, but can reach 40% in Ireland, where we are, for example, because water pipes are very old there, and there is not a lot of investment in water networks, due to the fact that there is no payment of water used by consumers in Ireland. After, it's possible to save again more than 20% of water consumption by managing people, especially in industries, to pay more and more attention about volume of water used every day. Industry are using about 20% of worldwide water consumption. At least by adapting and optimizing equipment used, it's possible to save again more than 10%. And not only in buildings. For example, in agriculture, agriculture uses 70% of the worldwide water consumption. In this area, issues are a bit different because water is used for irrigation and livestock feeding, so difficult to reduce the consumption. But we can help to use only the right level of water and avoid wastage. Means we help to regulate irrigation, to avoid to spray fields when it's not necessary. Maybe savings are less than in a building in terms of percentage, but not in volume. So as you can see, there is room for improvements here with consumers. So we saw that it's possible to save water, but it's not only to save money, but especially to conserve this resource as long as possible. But there is bad news, because with climate change, studies show that during the last 25 years, water available in the world decreased by 26% and population increased by 36%. The equation is not good. There is more and more droughts and more people moving from hot countries to big towns. But quantity of water in these towns doesn't increase, and we will have the same volume to spread to more people, so we can't. So it's necessary to start thinking about setting simple rules, because even if today consumers in towns just open the tap and water flows, with these new changes, tomorrow we should change habits. So first of all, we need to raise people awareness about ways to use less water daily. We need to avoid water wastage, we need to detect leaks as soon as possible, and we need to repair and maintain water pipes in good condition. Easy to say, but not easy to apply. Just a few examples. In France, water agencies launched a marketing campaign in town to ask people to pay attention about their taps to avoid wastage. It's written on the panel, don't let water flow anymore. Water prohibited waste. In Cape Town, South Africa, after a big drought in groundwater reservoir, utilities explained to people how to use only 50 liters of water a day by person. Yes, 50 liters, with only 2 liters for daily hygiene, 15 liters for a 90-second shower, and 2 flushes a day in toilets. Just imagine. And in California 2 years ago, government decided to limit daily personal water use to 210 liters. So as you can see, water conservation should become a priority everywhere because hydric stress is a reality today on Earth. So how can we help? Well, curiously, if you have a quick look around you, you will note that nobody knows about its own water consumption. For example, just ask to a technical director in a food firm how many cubic meters he uses a day. Same thing for a facility manager in a building or even you don't. But why? Just because you don't have this information available in real time. You can find this data once a year or month, maybe, written on your water invoice if you read well, because first thing you see on your invoice is not the consumption, but the amount you have to pay. And often you need to analyze the letter to find your consumption. So it's not every time very clear. So you are not really aware about how many water you use for everything at home, industry, and buildings. Again, because you don't have this data available when you want. Just a simple analogy I used to explain. Imagine you are in your car without dashboard, with your speed indicator, and you need to reduce your speed from 90 to 50 kilometers per hour. How can you do that without the speed indicator in front of you? This is the same thing for water consumption today. We need to reduce water consumption everywhere, but without water consumption indicator. So it's just impossible to do it right. You can't measure what you can't manage, what you can't measure, as Norton and Kaplan said. And remember what I said in slide 1, we can reduce by 20% water consumption in industries by just managing people, but only if you have this indicator of water consumption, isn't it? So this is the reason why we created a Robo, to provide in real time, everywhere, an indicator of consumption. Simple, but with IoT sensor inside, connectivity, and a useful platform to read data, analyze them, and be able to, it's very simple. With the solution, we measure water consumption everywhere sensors are installed. All sensors send data to a gateway with LoRaWAN protocol, and then the gateway sends all data to Robo platform in real time. In the platform, you can see water consumption in real time, the trend of consumption in a graphic, and you can download all data in Excel if needed. You can compare consumption of different sensors. You can sum consumption of different sensors to have a global consumption of an area, and you can set up alerts. You can set up a low threshold and a high threshold depending on your need. If the level is reached, then you receive a text message or an email to react immediately and to fix immediately the problem. And like that, you can save water. Just a simple example with a toilet. If the flush is blocked and there is nobody inside the building, it's a common situation now with the remote work, without indicator and alerts, if you let the flush like this during 1 week, water wastage is about 60 cubic meters, means 60,000 liters just in 1 week. Just imagine. And with the solution, technical guy can react quickly and fix the problem in less than 1 hour, means only 0.3 cubic meter wasted. So we try to use visual management into the platform to help people to read easily information about water consumption. And we continue to develop artificial intelligence inside the platform to allow people to react even faster to fix all issues with water networks. And results today are significant because we managed to save more than 30% of water just building one indicator. Awesome, no? So we calculated savings we did with our 2020 customers only, and it's equivalent to 5 Olympic pools, means more than 12 million liters protected and conserved thanks to our solution. And we should reach 25 Olympic pools in 2021. Some few examples everywhere in the world, as you can see in this slide. So in an airport in France, for example, savings are about 40%. We covered all the airport with sensors to be able to detect all unusual behavior of water network. As soon as there is a level reached by a sensor, facility manager reacts and go to see what happened. Another example, in a building in Paris, with 20 floors, more than 100 cubic meters a month are saved. We installed 2 devices by floor, and 3 leaks were detected in a year and fixed before a huge claim. Same thing with a warehouse in UK. 1 week after a solution was installed, the technical guy received an alert in the warehouse, and it was a leak. So his customer was very happy to have installed our solution because he would have lost some goods without the solution. In commercial centers in Ireland, France, and China, we help property owners to spread water consumption by store and to detect unusual consumption. We can compare consumption between 2 hairdressers, for example, fast food restaurants, and can help them to reduce water consumption when they clean kitchen, for example. At least another example, for L'Oreal, we help them to regulate external watering to avoid water wastage, and we install sensors into sanitary blocks and laboratories. And savings in 1 year are about 40% using our solution for all water points. So these are a good example of how to protect water.
Thanks a lot, Sylvain. That was an awesome presentation, and all the panelists were outstanding to share with us their use cases. I want to now take some couple of key points for conclusion. What is the motivation that we can find when as engineers or business guys, we are dealing with technology. The motivation that can be very inspiring for us is to find a better performance or a better ease of use or a lower cost versus competitors. I think it doesn't pay so much our life. So if we were starting to use technology for the good, for the planet, for the mankind, that's the ambition of protecting water. Birds has shown us how the digitization of water network distribution can improve efficiencies. AquaLabo has, with AquaMode, shown new sensors that can help to monitor many parameters for the water quality. Strega has one sensor to connect smart valves, which are good for different use cases, to stop waste of water, to take actions. And Robo has clearly demonstrated how to empower the end users to realize, to understand how much they consume and how they can save better and more water. So what we can say is we have here a large portfolio of proposal to improve efficiency in every country. It's replicable all over the world. It also says to us, LoRaWAN is not only for metering, as very well known today, but also for many use cases, many new, perhaps new IoT use cases. I want also to share a fact that this market of IoT sensors out of the metering are meeting a faster growth than metering, indeed. It's more than 13% of compound annual growth rate, according to market and markets. So that's for conclusion of the 5G. 5G as one, it's a key goal from United Nations. Second, we get inspired here, and we can find here a good way to have a global responsibility for the good and for the growth. So I want again to thank our sponsors, MachineQ from Comcast Group, Birds from Veolia, and Charter Communications. If you want to join the LoRa Alliance, you can find more details on web pages of the LoRa-alliance.org website. You can use the email address as well, admin@LoRa-alliance.org, to contact and get more details. So now I want to thank you all again for your attention. I want also to thank all the panelists for their tremendous efforts to present here today. Thank you. Bye-bye.